So to kind of recap our classification of matter and get in a little more vocabulary terms, matter can be split into two large categories, pure substances and mixtures. Pure substances then can be split into elements and compounds. And remember we just talked about element will be things off the periodic table, so like helium, hydrogen, which is diatomic, copper, different things. Those are all elements, all the same atom. Compounds, on the other hand, which can also sometimes be called molecules, right? We could have water, sodium chloride, just two examples. Notice different elements here. The big thing difference between substances and mixtures is that these cannot be broken down into smaller parts by physical means. So you can't break apart the O's from the H's in water just by physical means, like boiling or melting and so on. Okay? Same deal with elements. Mixtures, on the other hand, you can do that with. And sometimes you can use physical means. Sometimes you have to do filtration and things like that. So with mixtures, there's usually two large categories, homogeneous and heterogeneous. Homogeneous, homo meaning same. The particle size, so the substance that's being dissolved, the solute, the particle size is very, very, very small, so you cannot see the substance that's being dissolved with your naked eye. And these homogeneous mixtures are also called solutions. This would be something like Kool-Aid, or Gatorade, or tea, sugar and water, salt and water. You can't see the salt once you dissolve it. You can't see the Kool-Aid once you dissolve it. But through distillation, you can separate those things back out. Things you can do with your students, you can distill the Kool-Aid. It's pretty simple. You just take a flask, you put your Kool-Aid in there, cork, and you have a piece of tubing, glass tubing, that would come down and then come off here. And then you have some plastic tubing and another container sitting in an ice bath, okay? You start to heat your Kool-Aid. I wouldn't use a Bunsen burner, use a hot plate. Okay, as the Kool-Aid starts to boil, what actually boils is the water. So the water gas, vapor comes here. As it gets the cool air, okay, it's going to start to condense and reform here. And so you can actually separate. At the end, you'll have lots of clear, nice water here. It doesn't have the Kool-Aid smell. It doesn't have the Kool-Aid color for the students to see. And here you'll just have a lot of red liquid still left. Don't keep going until you burn the Kool-Aid substance. So you want to stop as soon as you get a good little bit of water coming out. If you don't have a setup like this at your school, you could always dissolve salt in water and just heat it until the water all comes off and the students can see that the salt is still there at the end. So there's two different ways to do this. The Kool-Aid demonstration is a lot more, it's neater, a lot more visual for the students, but you can do it with salt and water as well. Okay. In a heterogeneous solution, hetero meaning different, you can actually see the different particles here. There's two different types, suspensions and colloids. With suspensions, the particles are going to eventually settle out. Think Italian salad dressing. Here are my pictures, milk of magnesia. It's really thick, you can't really see through it. With colloids, the particle size here is intermediate, and there's two different types or ways you can think about this. Two different examples would be fog and milk. Both of these are mixtures and they're classified as colloids. And so how can you tell the difference? Let's go on to the next slide. You can tell the difference from the Tyndall effect. Okay? So you can tell suspensions from colloids and solutions because the components of suspensions will eventually separate. That's what I was talking about before. Like your Greek salad dressing, all that stuff falls down to the bottom. So you got to shake it up to get all those spices back in there, right? Oil and water eventually separate. Colloids can be distinguished from solutions using the Tyndall effect. So your colloid would be like your milk. A beam of light passing through a true solution, such as air, is not visible, but light passing through a colloid, such as smoky or foggy air, will be reflected by the larger particles, and the light beam will be visible. So you can talk about things that students have seen on movies where they have the laser beams and you can actually see them. They can't see them until there's people can put dust in the air or some kind of smoke. That's the only way you can see the light beams there. You can actually do, if you have a laser beam, you can actually shine it through some milk and some water so that the students can see what you're talking about there.